Let us continue with exercise 7b, coordinate geometry. Question number 9, we have to determine the ratio in which the straight line divide the segment joining 3:1 and 8:9. So here we have the line which join these two, 3, minus 1 and then 8, 9 at some point, and then we have to find the ratio. What to do? The ratio we can take it as k:1. Then what happened? This point which divide these two into ratio, it is on the line x minus y minus 2. So since we have ratio and the coordinate here, that means we have to apply section formula. And we should remember that this point which divide these two, it is on this line. So that means the value of x from the section formula, it will be here, and the value of y from the section formula, it will be equal there. Okay, so from there we can find out the ratio. So here this one will be our x1 y1, x2 y2. We have ratio m1 m2. We have the ratio, we have the coordinate, then we can apply section formula. So for x it will be k into 8 plus 1 into 3 by k plus 1. Then for y, k into 9 plus 1 into minus 1 by k plus 1. So for x we will get 8k plus 3 by k plus 1. Then k9, 9k plus to minus 1 by k plus 1. Then they already say that this point which cut the line A and B in the ratio k:1, it is on this line. So that means the value of x on this line will be equal to x on this point. The value of y in this line will be equal to y in this point. So that means now in this equation, in place of x we can put with this one. In place of y we can put this one. The rest remain same. Now our aim is to find k. So we can have ratio, we can find LCM. K plus 1, k plus 1 and 1. So both are same, we can take 1 as LCM. This one same, numerator remains same. This one same, numerator remains same. Here we have 1. So 1 to k plus 1, that means k plus 1 we have to multiply with 2. Oh, this one we write as it is. This one we multiply the sign inside. Minus to plus, minus to minus. Then minus 2 into k, minus to plus 2 into 1. So this k plus 1 we cross that side, it becomes 0. Then k and k we can put together. Those which do not have k, we take one side. 3 plus 1, 4. 4 minus 2 become 2. Then 8k minus 9k will be minus 1k. Minus 1k minus 2k, both minus, it will become minus 3k. So this is plus, take that side, become minus. Minus minus cancel, k we get it 2 by 3. So the required ratio is this 2:3 is to 1. So 3 we can cross that side, it is equal to 2:3. Then we will move on to number 10. We have the line segment joining the point A 4, minus 5 and B 4, 5. It is divided by a point P. Such a way the ratio is AP is to BP equal 2 by 5. They make it like this, up and down 2 by 5. The ratio will be same, 2:5. So we have to find the coordinate of P. We have x1, y1. We have x2, y2. Here that means this is M1, this is M2. So we can find the coordinate using section formula. In order to get the coordinate of P, we can apply section formula. So we will have 2 into 5 with x first. 2 into 4 plus 5 into 4 by 5 plus 2. Then for y, 2 into 5 plus 5 into minus 5 by 2 plus 5. So 2 into 4, 8. 5 4s are 20. 2 plus 5, 7. 28 by 7 we divide, we get 4. That is for x. 2 into 5, 10. Plus to minus, minus. 5 into 5, 25 by 7. 25 minus 10, 15. We cannot cancel, that will be the answer. So the coordinate of the point P, which divide the given line in the ratio 2:5 is 4, minus 15 by 7. Next, we'll move on to question number 11. We have to find the ratio in which y-axis divide the line. Okay, so we have the point 5, minus 6. Then the other side we have like minus 1, minus 4. Then this line, it is divided at some ratio, and that some point and some ratio. We don't know the ratio, we can take it case to 1. Then it so happen that this point is on y-axis. So we know that if the point is on y-axis, there will be no x-axis. So that means x will become 0, but y will have some value. Okay. Remember, when the point is on y-axis, it shows that x is 0, but y will have some value. So now we can find out the value of the ratio and the value of y. We have the ratio, we have the coordinate, we can use section formula. Our x1, y1 is this one, x2, y2 here. Then the ratio m1 we can take as k, m2 we can take as 1, then we can apply in the section formula. So it will become x, we know here for x part it is equal to 0. Then for y we know it is equal to y only. Then the ratio m1 we know k from here, m2 we know 1. So we can apply the formula k into minus 1 plus 1 into 5 by k plus 1. So k into minus 1 will be minus k. 5 into 1, 5. Then here we have only k, so this one we can cross multiply, become 0. So k plus 5. This is minus k, take this side, become plus. So k is equal to 5. Then we take for y, k into minus 4 plus 1 into minus 6 by k plus 1. So minus into plus, minus, minus to plus, minus. Then k we already know from there, 5. So in place of k we both replace with 5. Minus 4 into 5, 20. 5 plus 1, 6. Both minus, we can plus, sign remain minus. So if we cancel with 2 up and down, we get minus 13 by 3. So the required ratio is 5:1, and the ratio of that point on y-axis, which divide the given line, is 0, minus 13 by 3. Then we will see the next question. We have the line segment joining A and B is a diameter. So there is a circle. We have center C. Then there is point. We have point A minus 2, 9. Then we have point B, which is 6, 3. Then they say that mean the line is a diameter, which means C is a center. Then if we know that the radius of the circle are equal, so that means this part is equal to this part. If this part are equal, that means we get the ratio 1:1, which means C is the midpoint of the diameter. So we have here x1, y1, x2, y2. We can use the coordinate, find the coordinate of C using midpoint formula, because remember, diameter is the center is the midpoint of the diameter, because both the radius on both sides are equal. So then we can apply. C is the center of diameter. That is why it will be the midpoint. So we can use midpoint formula. X1 plus X2 by 2, Y2 plus Y1 by 2. X1 we have from here 5, sorry, minus 2. From here 3. So 6 minus 2 by 2 become 4 by 2, which we can divide 2. Then for Y part we get 9 plus 3 because both are plus, will be 12 divided by 2, which is equal to 6. So the coordinate of the center is 2, 6. Then next, number 13. We have to prove that the vertices of this 4 points, they are vertices of parallelogram. So if we have a figure parallelogram, maybe with the name ABC, D, we can say. So we know that the parallelogram have 2 diagonal, and both this diagonal, they used to bisect each other. So when we say bisect, that means this part is equal to this part is equal to this. That means this point here will be the midpoint. So if we could prove that the midpoint of AC and the midpoint of BD are same, it shows that they are the diagonal of the parallelogram, because diagonal of parallelogram bisect each other. Bisect means cut into 2 equal parts. So when we have 2 into equal parts, that means that point is known as midpoint. So let us find the midpoint of diagonal. It will be A and C, B and D. Okay, so using midpoint formula, we can use for that first. Here we can have 3 plus 6, 9 divided by 2. It will be, we cannot divide, so it will remain 9 by 2. Then 2 minus 3, so it will be minus 1 by 2. We cannot divide there also. Then let's see for B and D, if we take it. So 5 plus 4, again 9 by 2. 0 minus 1 will be minus 1 by 2. So we see that the midpoint of both the diagonal are same. So you see 9 by 2, 9 by 2, minus 1 by 2, minus 1 by 2. So if midpoint are same, it means that they bisect each other. So if they bisect, the diagonal bisect each other, it shows that the given figure is a parallelogram.